Okay, so we're going to take some time here and look at the binomial probability throughout Chapter 8. This video is going to put all the pieces together. You may find subsequent videos posted in Classroom as far as individual pieces of this, but this is going to be the whole unit, the whole concept of binomial probability put together into one video. So we're going to look at an example where a game of chance is played 3 times, for which the chance of winning each game is 0.2 and the plays are independent. So we want to make a probability distribution. To make a probability distribution, we know that x, p of x are going to be the columns in that binomial distribution. So what we're going to do is say, well, how many times, if we play this game 3 times, how many times can we win? We might win 0, 1, 2, or 3 times. Okay. Now to facilitate this, what I want to do is I want to make a tree diagram. Okay, so let me move over here. Am I going to have room there? Let's go here. And we're going to make a tree diagram. Each time we play the game, we're either going to win or we're going to lose. So here's our tree diagram. Okay. Now in a little bit, we'll talk about how I can figure this out without having to do the tree diagram over and over and over again. But the probability of winning is 0.2 each time, because they're independent, because each play is independent. The probability of winning doesn't change. It's always 0.2, and the probability of losing, therefore, will always be 0.8. So when I go to make the table, what's the probability if I win 0 times? What's the probability that x is 0? That's going to be the probability that I lose, lose, lose. So that will be 0.8 times 0.8 times 0.8, which is going to be 0.8 to the third, or 0.512. So the probability that I lose all 3 times, the probability that I never win, is 0.512. The probability that I win 3 times, that would be a win-win-win. So that's 0.2 times 0.2 times 0.2, and 0.2 to the third is 0.008. So the probability that I win all 3 times is 0.008. Now, what's the probability that I win once? Okay, if I want to talk about the probability that I win once, well, I might be tempted to say that that's going to be 0.2 for the win times 0.8 for the 2 losses, but that only takes into account win, lose, lose. That's this track here, win, lose, lose. But could I also lose, win, lose? And couldn't I also, therefore, lose, lose, win? So that's going to be 0.8 for the loss, 0.2 for the win, 0.8 for the loss, 0.8 for each of the 2 losses times 0.2 for the win. So notice that 0.2 times 0.8 times 0.8 is 0.128. Each one of these is 0.128. Because there's 3 different ways to win once and lose twice. So what I need to do is multiply. Notice what I'm going to do is 3 times the 0.128, and we get 0.384. So 0.384 is the probability of winning once. To win twice, well, let's just go here. To win twice would be like a win-win lose, which looks like it's going to be 0.2 times 0.2 times 0.8, 0.2 times 0.2, that's each of the 2 wins, times 0.8 is 0.032. But again, that's only one way to win twice. What about win, lose, win? And what about lose, win, win? There are 3 different ways to win twice, and so we're going to simply multiply that by 3. And the probability, therefore, of winning twice is 0.096. Okay, so let's come back over to our sheet here. Now that we've made that probability distribution, for those 3 plays. And where we're going to get to in a little bit is a faster way to make that probability distribution than having to go to the tree diagram every time. But a little typo here first. This should say, what's the probability of x when x equals 2? So find the probability of winning the game twice. The probability of winning the game twice is simply going to be 0.096. Here's my probability of winning the game twice. Find the probability that x is less than or equal to 2. Well, that would be I win 0 times, 1 time, or 2 times. The probability that x is less than or equal to 2 is the sum of all of those. 0.512 plus 0.384 plus 0.096 is 0.992. Now, I probably could have also figured that out by saying I'm excluding the 0.008. So I could just do 1 minus the 0.008. And that's not writing. 1 minus the 0.008. And we have 0.992. So we could get that either way. Now, lastly, what's the probability that x is greater than 1? Notice that x being greater than 1 does not include the 1. So that would be that x is either 2 or 3. So I'm going to add the 0.096 plus the 0.008, and we get 0.104. So those probabilities aren't too bad, I hope. Okay. Now, what's the expected value of x? In other words, if I played the game 3 times, how many times would I expect to win? So I'm going to remake my table down here. X, just make it cleaner. X, P of x is going to be 0, 1, 2, 3, 0.512, 0.384, 0.096, and 0.008. Now, if I'm going to do this out by hand, I'm going to make another column that's x times P of x. Because remember, the expected value is equal to mu, or the sum of the x P of x values. That is what we call the expected value of x. 0 times 0.512 is 0. 1 times 0.384 is 0.384. 2 times 0.096 is 0.192. And then 3 times 0.008 should be 0.024. If now I add those up, 0.384 plus 0.192 plus 0.024, we get 0.6. So the expected value, mu, the expected value of x would be 0.6. So I would expect to win 0.6 times. That's if I play the game 3 times. Now, if I played this game 3 times, and then 3 times, and then 3 times, so I played it 3 times, 10 times, so it'd be what, 30 times? I would expect to win 6 of those times, okay? Now, as far as the standard deviation, I've given you the formula, but I've also mentioned here's what I want to do on the calculator, okay? So on the calculator, I'm going to go to Stat, Edit, and let's clear those lists. And my L1, I'm going to put the 0, 1, 2, 3. L2 is going to be the probabilities of 0.512, 0.384, 0.096, and 0.008. Okay. So now we're going to go to Stat, Calculate, one variable statistics. In the past, we've always had L1 is just where we put the data. Okay. Now imagine, oops, didn't want to do that. Stat, calc, one variable statistics. The frequency list, how often does this occur? Well, that's going to be my L2. That's my frequency list. Okay. And now I'm going to calculate, and you'll notice that x bar is equal to 0.607. Okay. Let me make sure that I have the right numbers in there. Oh, that's why. That should be 0.512. Wasn't looking right. Now stat, calc, one variable statistics, L1, L2 is my frequency, calculate, and 0.6. That's better. That's what we were expecting. So x bar is 0.6, mu is 0.6. My expected value is 0.6, okay? Now that's not my standard deviation. My standard deviation, remember, is sigma. Sigma is right here, 0.6928. That's my standard deviation. We'll talk in the future about what standard deviation means, what it is, but here's how I calculate it. The variance, remember, is simply sigma squared. So 0.6928 squared, and our variance is 0.4800. Okay, so there's our standard deviation and our variance. Okay, now let's go a little bit farther. Suppose that we don't play this game 3 times, we play it 5 times. Suppose we play it 10 times. Suppose we play it 100 times. I don't want to make a tree diagram over and over and over and over. Okay, so here's where we're going to go. Here's how we're going to look at and how we're going to handle this. We're going to say that n represents the number of times that we're going to play the game. That's 5 times. We're going to say that P is the probability of winning. And if you remember, we said the probability of winning was 0.2. Q is 1 minus P. That's the probability of losing. That would be 0.8. That'd be the probability of losing, right? 0.2, the probability of winning. 0.8, the probability of losing. Okay. So what I'm going to do is I'm going to take P sorry about this. P plus Q to the 5th, and I'm going to expand that. Okay. I'm going to expand this. And if you recall, we talked about combinations, right? So let's expand this. Now here's the formula. Let me take a little breather here and talk about combinations. We talked about NCR. So suppose N is 5, C 3. This means we're going to play the game 3 times. Well, if I would make my tree diagram, win, lose, win, lose, win, lose, I don't really want to do all that out. But what I'm going to look at is if I play the game 5 times, how many different ways are there to win the game 3 times? I could win, 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 lose, lose, win, win, lose, win, lose, win, win, lose, lose, win. And I can go through and I can find all the different ways. But how do I know when I found them all? In order to know that I found them all, I pretty much want to know how many there are going to be. Okay. And again, I suppose we could take some really boring time and do the tree diagram with 5 layers. You go right ahead. Notice I keep erasing this because I don't want to do that. Well, we've talked about the probability here being 5 choose 3 is going to be 5 factorial divided by 2 factorial, 3 factorial, which is 5 times 4 times 3 factorial divided by 2 factorial, 3 factorial. 2 factorial is just 2, and so that's 10. Well, what's 5 choose 2? That's going to be 5 factorial over 3 factorial, 2 factorial, which notice is exactly the same, except that the order of multiplication in the denominator is reversed. Okay, so that's going to be, again, 10. Well, wait a minute. We talked about this in class. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and so on and so on and so on. Notice that this is 0, 1, 2, 3. 5 choose 3 is 10. 0, 1, 2. 5 choose 2 is 10. Okay, so here's where this plays. If you recall the expansion, how to do a binomial expansion, I've shown this several times, right? P plus Q to the 5th, I'm going to take the 5th row of Pascal's triangle as my coefficients. We know that this is going to happen. We're going to have P to the 5th, P to the 4th, P to the 3rd, P squared, P to the 1st, P to the 0, Q to the 0, Q to the 1st, Q squared, Q to the 3rd, Q to the 4th, and Q to the 5th. Now, if you recall here, P is the probability of winning, and Q is the probability of losing. Notice that there's only one way to win 5 times. There are 5 ways to win 4 times. There are 10 ways to win 3 times. There are 10 ways to win 2 times. 5 ways to win once. There's only one way to win 5 times. So really, what's the probability that I will win twice? Okay, for number 7, the probability I'm going to win twice, I just come right here. And that's going to be 10 times 0.2 squared times 0.8 cubed. 10 times 0.2 squared times 0.8 cubed. 0.2048. What's the probability that I will win 4 times? Well, that's the probability right here. Notice that I have P to the 4th because I'm going to win 0.2. I'm going to win 4 times. I'm going to lose once. But according to that selection there, according to Pascal's triangle, according to if there are 5 games and I choose any 4 to win, 5 factorial over 4 factorial 1 factorial is simply 5. So I'm going to multiply that by 5 because there's 5 ways to win 4 times and lose once. So 5 times 0.2 to the 4th times 0.8, and that's 0.0064. So the probability that I win 4 times is 0.0064. Okay. Now, what's the probability that I will win 2 or fewer times? 2 or fewer, yes, it's or fewer, not or less. 2 or once or nonce. So now I'm going to add these up. That's going to be 10 times 0.2 squared times 0.8 cubed. That's this term here. Plus 5 times the probability I win once. That's this term here. And then the probability that I lose all 5 times. Okay. So that's going to be 10 times 0.2 squared plus, times 0.8 to the 3rd plus 5 times 0.2 times 0.8 to the 4th plus 0.8 to the 5th. 0.9421. So the probability that notice my probabilities always 3 or 4 decimal places. 4 is better, 3 is okay. 2, no good. 1, no good. 5, you're being ridiculous. Okay, so the probability that I win 2 or fewer times would be 0.9421. Okay. Now, before we go on to number 10 there, what's the probability that you will win at least 3 times? Let me show you the calculator here. Okay, so if you look at my pointer here, I'm looking at the VARS button, and above it in blue it says distribution. Second, distribution, and if you go down this list, all the way down to number A, you will see binomial probability distribution function. To do the binomial probability distribution function, how many trials? We have n trials. Okay, we have n trials. I'm going to do number 7 first. We have 5 trials. P is the probability of success, which is 0.2. Notice the calculator does not ask you for the Q value. It does not ask for the 1 minus P value. It figures it out all by itself. Okay, and then the X value, the question is, what's the probability that we will win twice? So my X value is 2. Paste, enter, 0.2048. Second distribution, number B, binomial, whoops, no, I'm sorry, I'm wrong. Second distribution, let's just go down the list. We want number A, the binomial PDF. If we played the game 5 times and P is 0.2, what's the probability that we will win 4 times? That is 0.0064. Okay. Now, number 2, what's the probability to win 2 or fewer times? That's not the PDF. PDF is probability distribution function. What we want, this is the mistake I made a moment ago, we want to go down to number B. Notice it says binomial CDF, cumulative distribution. Now you're going to have to use your brain, and you're going to have to remember that we've got 5 trials. P is 0.2, and the X value means or fewer, or fewer. So I simply do 2. That's the probability of 2 or fewer wins, 0.9421, 0.9428. That would be the probability of 2 or fewer times. So number 10, whoops, where did I go here? Okay, so for number 10, what's the probability that you will win at least 3 times? So if I sketch this out, we can win 5, 4, 3, 2, 1, or 0 times. I want to know the probability that I will win 3 or more. If I want to know the probability that I will win 3 or more, I'm going to do 1 minus the probability that I will win 2 or fewer. So the only choice I have there is 1 minus the 0.9421. Okay, which is 0.0579. Now you can do it 1 minus that answer on the calculator, 0.0579. You can do it that way. Okay. Now what's the probability that I will win more than 3 times? Winning more than 3 times means I'm going to win 4 or 5 times. So what I need to do is I need to do distribution, binomial CDF, more than 3 times. That's the probability I win 4 or 5 times. That's 1 minus the probability of 3 or fewer. So the probability, 5 trials, 0.2 is the probability of winning, 3 or fewer. The CDF is or fewer. If I said or fewer enough times, that's going to be 1 minus 0.9933 is going to be 0.0067. So the probability that I win, excuse me, 4 or 5 times, probably going to win more than 3 times, is 0.0067. So you do need to have some understanding of the English language. What do I mean by or fewer or more, at least, more than, no more than? You want to know those comparative words. But that's the binomial probability distribution frequency or function, I'm sorry, in a nutshell.